What's going on? This Tools and Tactics Live. We got Tools and Souls in the house. Looks like we got Renegades. We got Joshua Wilson, one of our members, Texas Southpaw, Backwoods Bay Small Engines, and some others in there. How's everyone doing? How you doing?
I'm actually a little under the weather right now.
Oh, well.
I don't know what happened. I've been dizzy for about the last 4 hours or so.
Okay. Well, hopefully, if we need to do something else, let me know. If you can most certainly sit this one out, let me know.
No, I'm brave.
Hold on.
I do want to know why there's only 2 thumbs up, though.
I want to know why I can't see the comments.
I can.
Let me see here.
I can tell you this. It's
Oh, there we go. Okay, I fixed this somehow. All right, so we're talking about PVC connectors, right? These things here. And I've been doing a lot of electrical mistakes to avoid videos. What's up, Joshua Wilson? Had a pretty good day today. Wanted to pass along the positivity. Hey, man, I appreciate that. Thank you, sir. Joshua Wilson is one of our members, and he sends us both quite a few things to test out and show you guys. And yeah, thanks, Joshua Wilson. Always appreciated.
Yeah, it's I one of the best members of the community out there. Very supportive, always supportive. We appreciate it greatly.
Yeah.
How you doing,
Backwoods? Small engines, BBSE. I don't know, Backwoods, whatever. All right, so we've been doing these electrical mistakes to avoid videos, and I could bring one up if I wanted to. I suppose I could. We'll do that in a minute, but I mean, they're almost going viral, man, which is great. I mean, we're knocking on 100,000 on a lot of those electrical mistake to avoid videos. Now, a lot of them, some people don't know what's going on. And we are here, we're trying to build a electrician community. Anybody that doesn't know about electrical, more than welcome. Glad to have you. When you do shorts, your demographic gets shifted. I'm sure you've seen the most views I typically get on a long format, about 1,200. I got 21,000 subs. So when people sub from the shorts versus people subbing from the long format video, it's going to be a different kind of audience. It just is. That's the way it is. So I've been doing shorts that are less informative and maybe more geared towards somebody to be able to identify stuff immediately that's in the electrical trade. And I want to help as many electricians out as possible. I just got an apprentice a job and gave hundreds of dollars of tools. That's my whole goal here, is to make a dent. And we talked about this the last stream, and we've been doing that, and we're going to continue doing it. Now, a lot of the comments that I'm getting on these videos, what's up, Kansas? Hey, man, I got good news, dude. I found the flashlight. I've lost this thing. And I found it about 17 times now. I did a video on it, and then the whole room was turning upside down because we had to do the floor in that room. I unboxed it, put the video out, and then I freaking lost it. Then I found it again, used it for a couple of days, lost it, found it. Dude, it's going on the keys, and we're gonna get one out soon for a full review on it. But this thing is pretty bright. It's pretty cool, and it lights up. So it lights up the whole area. And what's really cool about it is once you turn it off, it stays like glowing. Like, I don't know if you can see it where it's green. It almost glows in the dark once it's done. This thing is pretty cool. USB-C, I believe. Yeah. So anyway, number one comment: where is the plastic bushing on my plastic connector? And these are professionals that are commenting, so I'm getting.
Are they
in the dark? Exactly, it does.
Wait, are they professionals or are they
Well,
professionals?
I don't know, but they know enough. They know enough to where it sounds like an inspector's called him out on it before. So I'm here to call out the inspectors, I guess. I don't know. We'll see how this goes.
I will
Uh,
just say on every single one of your electrical mistakes to avoid videos, every single one of them, I comment the same thing every time.
yeah,
A professional did that.
yeah. It's getting bad out there, guys. It's getting bad out there. Anyway, all right. So my thought is that the connector is made of PVC. Um, that's where it ends. I mean, I've got other points that we're going to hit, but this thing is made of PVC. So why are we going to put a PVC connector on it? I don't understand what it's doing. It seems like an overreach to me, and that's one thing I can't stand. I can't stand overreach. I will go out of my way to not give somebody overreach or the runaround or reach around, whichever one. I don't want to do it.
Did you just say you go out of your way to give them a reach around?
That's correct. So,
All right, I want to make sure.
Like today, I mean, I was driving by a gas station. I noticed they had the whole thing torn up. Got out of my car, put my cards out, and I handed it to the guy. He said, "Can I help you?" I said, "Man, I'm here to help you." I said, I don't want you to get the runaround from the city. If you need anything, let me know. I asked if a certain company was going to be doing the install. They said yes. So are you doing PVC? Are you doing rigid? Are you doing plaster bond? What are they doing? They're doing plaster bond. And I was going to go over, don't put rigid in the earth without wrapping it with at least some 3 mil tape, because we've considered the soil acidic here to where we're seeing rebar get corroded in the ground. We've seen rigid get corroded in the ground within 2 or 3 years. So you obviously don't want that on your gas pumps that are feeding electricity to the pumps. So I go on my way to try to help out anybody that's getting something unnecessarily done. It's just an overreach, man. The guys don't know their job. It is what it is. It sucks. So I'm trying to educate you guys so you guys will be able to at least navigate the code book when somebody tells you something ridiculous like this.
A lot of the code book, not all of it, but a lot of the code book is just common sense. Such as, does plastic carry electricity?
Yeah. So let's look at that, right? Everyone quotes 300.4. So what does 300.4 says? 300.4 says here. Pull it up here. And I will show you.
Where's Paul W? We need the whiteboard.
Yeah, we need the whiteboard. I got everything up except for this one. It says where raceways, which is a conduit, contain number 4 or larger. So if you're number 4 or larger, insulated circuit conductors, and these conductors enter a cabinet, a box, an enclosure, or a raceway. The conductors, the wires, shall be protected by an identified fitting providing a smoothly rounded insulating surface. Okay. Unless the conductors are separated from the fitting of the raceway by identified insulating material that is securely fastened in place. It says that on here. They're quoting 300.4. Okay. Exception where threaded hubs or it says bosses. Never seen that. That are integral part of a cabinet, box, enclosure, or raceway provide a smoothly rounded or flared entry for conductors. Now, I've heard of inspectors actually calling this in the Dallas area as well. Not trying to call anybody out. It's just a city around here. It says insulated on there. I don't see how this isn't insulated. So everyone's quoting 300.4 G specifically. And it says on here that you don't need it. But we're going to go further than that because I'm getting so much kickback from this. We are going to go further, and we're going to do it right now. So right here, on the TV, I can zoom this in, or we can do something else. We'll see what happens. I could possibly bring this up as a window as well. I might just do that.
You should.
Can I do that? Yeah, I do. Okay.
Who did she think she's fooling?
All right, so let's see here. I got a lot of windows open. All right, present, share screen, window. What am I looking at? What is that? Is that
a very, very, very tiny appendage between your legs?
I'm almost afraid to click on that. Yeah, we'll find out.
That's a nipple.
Okay, no, it is. It is. Okay, good. Yeah, so now I can blow it up. Pushing. Right there. Where conduit enters a box fitting or other enclosure, a bushing or adapter shall be provided. Sorry, this is stupid. I can't read it, dude. I'm blind. It says where a conduit.
Here, I'll read it.
Yeah, read it. There you go.
Where a conduit enters a box fitting or other enclosure, a bushing or adapter shall be provided to protect the wire from abrasion unless the box fitting or enclosure design provides equivalent protection. Informational note C 300.4G for the protection of conductors 4 gauge or larger at bushings.
Right. So equivalent protection.
It doesn't carry electricity.
I mean, it makes sense to me. Everyone seems to think that we have to have these. So this is what everyone wants to see. Everyone swears that's what we got to have. Would be a plastic bushing like that.
Going into metal, when it's going into metal, such as that,
yeah,
it makes sense because if it does, at that point, fray or arc at there, you're energizing that entire metal casing.
Yeah.
But through regular old everyday PVC and whatnot, it does not make sense.
If somebody wants to make the argument that this gets chewed up with, pulling string, whatever you're doing, I would agree with you. If you got a nick in this and it's clearly damaging the jacket of your wire, it would be up to the authority having jurisdiction, which would be the inspector, to maybe require you to put a bushing on there. I can entertain that idea, but dude, if I show up and there's no nicks in this, it's good to go all day. The whole equivalent protection covers the whole argument.
Right.
When you have a bonding bushing on Article 250 and it says that anything 250 volts to ground must be bonded, you're not putting bonding bushings on PVC. I certainly hope not.
It wouldn't do you any good.
You know what I mean? Let me try and catch up with the chat. I need an 80-inch monitor. Yeah. Well, I've got one. I could look back here, but you wouldn't be able to hear me. It's good. Why are there so many exceptions to the rule? There shouldn't just be another section that says it follows under the bylaw. Yeah, man, the code book is written by a bunch of lawyers, and they just keep adding more stuff. But honestly, once you know how to navigate this thing, it actually becomes really easy to understand what's going on because it will jump you back and forth. You can go down the wormhole of this and go in circles, but it's actually written really good for how much information's in this. You can figure out anything you need to know. You just got to know how to read the code. And that's where the test comes into play because they know that it's so hard to read. They'll throw all kinds of different questions at you. So yeah. I wouldn't sell that bushing. Do you want to know why? because I'm not going to risk my wire burning the threads when pulling, and I can't get the lock ring on as easy. If tags is around, you know something is going to go wrong. If there's a section of code book that says, is there such thing as too much protection? No, the code is to the minimum. It's to the minimum standards. So that's where you get into the whole overreach thing, man. We're here to inspect, not expect. So you can easily swap that breaker out to 20 amps to a 30 once I leave. You know, it's going to be 21 in there. If this thing doesn't have a hole in it, it's not nicked up, guess what? That's a green all day. You can only inspect with what you have there. So in the same respect, you know, the job's got to be done for me to start inspecting. I'm not going to inspect it when you're not done. I can't just say, okay, you're done halfway and pass, in the same sense that I can say, well, this could happen. I'm going to fail you. It's a two-way street there, you know?
Mm-hmm.
So you can install double bushings like a hamburger bun. Yeah. Mike Holt resents that. I'm sorry I'm late to talk to you guys. What's up, BWs? Codebook as guidelines, inspector has ultimate say. That's absolutely correct, but that still doesn't make it right. And that's what I hate the most is these guys that just run over. I don't think I've ever seen a bushing ever on these. I've never seen a plastic bushing. Everyone even asked for one. These are metal. These are metal. These are plastic. This is a Carpex connector. They use metal lock rings. You might have what if you have one of these here that takes what you call a chase nipple. So you got a close nipple, which is all threads, and you got a chase nipple, which goes flat on the top, and it's designed to screw into this. Are you going to ask for a bushing on that? It's metal.
Nope.
You know, it's the whole thing's crazy, man. The internet's crazy, but there's so many comments about needing a plastic bushing on a PVC connector. I just couldn't believe it.
What we truly need out there are more inspectors that by 8:30 they're sitting on their recliner, no pants, watching old episodes of MASH, and telling you to send a photo.
Yeah.
That's what we really need.
Yeah, that is what we need more of. At the beginning of this book, it goes into more or less what you can and can't do and how to present it.
You have a question?
And it goes on to say here, mandatory rules are those that identify actions that are specifically required or prohibited and characterized by the use of the term shall or shall not. Right? The enforcement, the code is suitable for mandatory application by governmental bodies that exercise legal jurisdiction over electrical installations, including signaling and communication systems. The authority having jurisdiction for enforcement of the code has a responsibility for making interpretations of the rules, for deciding on the approval of equipment and materials, for granting special permissions contemplated in a number of the rules. Now, listen to the special permissions. By special permissions, the authority having jurisdiction may waive specific requirements of this code or permit alternative methods where it's assured that equivalent objectives can be achieved by establishing and maintaining effective safety. So, at the end of the day, someone said that I wasn't legit if I didn't make them put a plastic connector on there, dude. I don't know. That guy needs to grow a set and tell his inspector, show me in the code where it's not equivalent. Equivalent protection is equivalent protection. So there's the case in point there, dude. That's the nail in the coffin on that. I'll show you a throated connector.
I'm gonna leave the studio for a minute. I'll be right back.
Right on.
I'm gonna try restarting my computer.
Okay, that'll make you feel better. All right, so that's a throated connector. those have a plastic insert that would essentially go. It's inside. It's inside of there. And I can't tell you how many times we've been pulling wire and those things pop out. And once they pop out, they're out forever. So if we're and they don't go back in like they ever were. So that connector, essentially the whole thing should be replaced. Or you should have to put a plastic bushing on it, technically, if it's a spec or something. But if that thing is suitable to protect the wire, I don't see how the edge of this can't be. I make my inspectors cite code. Yeah, you should. Everyone needs to. They need to know their job. Metallic liquid type fitting, that is. Here's a question. What about insulated collar on metallic liquid type? Need a bushing? Yeah, that's exactly what I've got here. So not a plastic bushing, no, because equivalent protection. If you are entering with 250 volts more to ground, where you got 277 to ground because you got 480 or three-phase, whatever you got, you would put a bonding bushing on it because you're, flex. The rules for flex gets interesting. Let me go to flex here real quick, which would be should be 330. Find it here for you. This is where you've ever heard somebody say you can't consider the flex as a ground. And you might get that spec where it says you can't run flex over 6 feet. This is where this code comes from. And that's where they're getting their specs from, is this specific code here, which is going to be, should be LFMC. Here it is here, liquid, flexible, metallic. Yeah. So, total souls is not here. Okay. If we go here to grounding and bonding, 250.134B. So see, it's going to take you to, you're in the category of liquid flexible here, which is 350.60 grounding and bonding. But then it will take you, it says go to 250.118 or 250.134. So it bounces you around pretty good to where you can figure out. Looks like he's here. What's up?
Man, I've been sitting back there for like 2 minutes.
I just glanced up.
Not my fault.
Yeah.
By the way,
that's
got a plastic coating inside.
Wow, hot Tortinos, man. That's a cheap date right there. Dude needs a better mic. I need a better mic?
Yeah.
Oh.
What the heck? Hold on, it says my
might be better.
My computer, my camera became unplugged.
Oh, is that what was wrong there?
No.
Okay. So
I'm just having all kinds of trouble.
This is very misunderstood here, okay? So this is the requirements for grounding. So this is the rule, okay? Types of equipment grounding conductors. The equipment grounding conductor, so we're talking about what you would be considered as an actual ground that would get current back to the neutral, because your grounds are going to take objectional current back to the source. That's the whole point of the ground, right? So we've got equipment grounds, which are usually the green wires and maybe the bare inside your Romex that are going back to the panel. That's what an equipment ground is. The user errors must be contagious. All right. So.
My goodness. Shut off your, you restart your computer and then you got to fight to get it back to being right. Dang.
Yeah. All right. So the circuit conductor shall be a combination of the following. Okay. A copper, aluminum, or copper-clad aluminum conductor, which is a wire. Or conductor can technically be something that just carries current. So you could use the building steel as a conductor. For example, insulated, covered, or bare, and in the form of a wire or a bus bar of any shape. Yeah. Rigid metal conduit, intermediate metal conduit, which is like rigid conduit. It's a little bit lighter, a little bit thinner wall, still threadable. EMT, electrical metallic tubing, listed flexible metal conduit meeting all the following conditions. So this is where you run into that weird gray area of transformers, and you've got flex that's coming off of that transformer. Now, directly off the transformer, we don't have a breaker. We come straight off of a created almost service. They're not considered service conductors. They're considered what we call secondary conductors. But they don't have any overcurrent protection, just like a service at a house, okay? So just like a service at a house, we got to do special things to maintain the bond. So this is the rules for listed flexible metallic conduit, which would include flex and also seal tight, like what Joshua Wilson was talking about. The conduit is terminated in listed fittings. Okay, so first off, it's got to be the proper fitting for the material. You can't put a seal tight connector on flexible metallic conduit. You can't put a flex connector on seal tight, obviously. The circuit conductors contained in the circuit are protected by overcurrent devices rated at 20 amps or less. Instantly, services are out of the equation here because you don't have overcurrent protection, right?
Yeah.
So if you're over 20 amps, you're out of the question. That's why whenever I see like seal tight or something ran, I'm getting to the next point here. The size of the conduit does not exceed metric designator 35, which is metric, and then trade size 1.25 inches. So your flex can't be larger than 1.25 inches. You can't fit 3/0 in 1.25 inches. You can't fit very much in 1.25 inches. So anything over 1.25 inches, and it says all the following, not just one. You can't just pick one. You got to be all of them, right? So we got to be less than 1.25 inches. We got to be less than 20 amps. And wait for it. It says the combined length of the flexible metallic conduit and the flexible metallic tubing and liquid tight flexible metal conduit, which I've been covering this whole time, does not exceed 6 feet. So that's where you get to your 6-foot rule for medical, because medical requires double grounding, requires redundant grounding. And if you're trying to use metallic flexible conduit for your grounding as like you would EMT, you can't be over 6 feet. That's where that spec comes from. That's why a lot of the engineers will say no more than 6 feet, because they know that it's not a suitable ground path.
Yep.
So then it goes on to talk about different where flexibility is necessary to minimize transmission of vibration in equipment to provide flexibility. Equipment that requires movement after installation, equipment grounding conductor shall be installed. So that would be transformers, motors, something like that. That's where you have to put a ground inside of that raceway. Now, what you can't do on Encore's meter, which is a utility company here, they're the contractor, you can't put grounds in Encore's equipment. The utility company does not want grounds in their service. So that's why a lot of contractors run PVC, because you don't need a bonding bushing. You can't really ground the thing anyway. And all these guys that are adding all this extra BS after you've already installed a service, it's just BS, dude. PVC is not conductive, like we mentioned. That was your point from the very get-go. It's just an overreach, man. That's all there is to it. It's just an overreach. Can it be over 6 feet if it has an EGC? Yes. And also somewhere in this code, it talks about if you're on a rooftop. If you're on a rooftop, because contractors tend to stand on pipes on rooftops, you have to have an equipment ground in the raceway going to AC equipment, because if you break the connection where, let's say this is screwed in, whatever, and someone stands on that and it breaks a little bit of the connection there and it's metal, being EMT here, you're going to lose your ground. And when you don't have grounds, I mean, you're like a bird on a high wire. You know, it goes back the whole thing we've been hitting hard about the pools. You know, you want to be the same potential. You want to be able to get that current back to the source. You want to maintain everything the same potential.
Yeah. Like I said, it just goes back to common sense, though.
Just watch out for somebody trying to sell you the tactics guide to superior wiring and insulating.
A lot of it just goes back to common sense. If you're near metal, you want it to be grounded.
Yeah.
If it's underground, right?
Right.
It's grounded. Just if it can become energized, that is, if it can carry electric current, you're going to want to make sure that current has somewhere to go that ain't you.
Right. So that was Article 250.118. And yeah, that's pretty much where you get a lot of those specs from. We could go on to, we may as well hit it while we're here. Equipment grounding conductors that are smaller than number 6. This is how the code starts off. So we are in 250.120C. And what you're going to see here, the heading of it says conductor smaller than number 6. Okay. So we're not routed with the circonductors as permitted in other articles. I'm not going to bore you with all the details. Equipment grounding conductor smaller than number 6 shall be protected from physical damage by an identified raceway cable armor unless installed within hollow spaces of framing members or buildings or structures were not subject to physical damage. So I get this question a lot. Does that number 6 that you're having them run external have to be protected? Why are they allowed to run it bare? Why can they just run it down the wall without a raceway? And that's where you get that code from. It says here, smaller than number 6. So if you're number 6 or larger, then you're good to go. Number 6 for ground rods, number 4 for cold water, typically in a house. That's usually what you see. So that right there, you don't need to have protection for physical damage for those wires. There is somewhere else in this code that talks about circuit conductors and how they have to be strapped and all that stuff on branch, but that's not grounding. That's something else. And then while we're talking about it, we don't require this. We could, but honestly, man, it's such a racket. When you are running a ground for equipment, whatever it is, just like in 200.6 here, we're talking about the neutral and how you can't tape it white if it's black. If you're larger, if you're number 4 larger, that's when you can. It's verbatim in the grounding and bonding code. So this code here says here, number 4 or larger. So what it says, an insulated grounding conductor number 4 or larger shall be identified by one of the following means. Now, when it says insulated grounded conductor, you have grounding and you have grounded. Grounded is your neutral. Grounding is your grounds, your green, your earth, your bare, whatever it is. This is in 200.6 because we're talking about neutrals now. So what it says here is an insulated grounded conductor, number 4 or larger, shall be identified by one of the following means. Okay. This is one of the following. A continuous white outer finish or gray outer finish. 3 continuous white or gray stripes along the conductor's entire length, other than green insulation. And at the time of the installation, by distinctive white or gray marking at its terminations, this shall encircle the conductor or insulation. That's all it says. Okay? It doesn't say anything else. And we started with, what are you scrolling through? We started with
nothing. I was looking at things that are electrifying.
Nice. We started with number 4 or larger. So automatically anything smaller than number 4 is out. So that's why you can't identify neutrals white when you have black wire if you're smaller than number 4. And it's verbatim, just like that in the grounding code. Verbatim. So you can't take black wire and use it for a ground if it's smaller than number 4. And tape it green. When you're running your ground rods and stuff, we'll let you run black. You can tape it. It's on the outside of the building. We know what it is. We're not going to make you strip it. You know. That's a grounding conductor right there. Yeah. My dad used to say, if common sense was changed, most people couldn't buy a cup of coffee. Yeah. That was back when we could coffee for 50 cents. That's awesome. Wait, my background music. Yeah.
If you don't visit Facebook for a long time, then all you start getting as a guy on your feed is chicks.
I don't do Facebook at all, so
I was literally just scrolling through Facebook right then, and that's all that was showing up.
That's all you
like
got.
The photo part of it or whatever. That's all that was showing up. It's ridiculous.
Nice,
but definitely grab some attention.
Yep, and then last but not least, since we're addressing all of the comments about
Fake ones.
All the shorts, someone said that you can run number 6 to the cold water ground. Your main ground, your system bonding jumper, your main bonding jumper, whatever it is, your cold water ground, all that stuff is going to be sized off of 250.66. So that code here says, let me see here, specifically, 250.66 is the chart that talks about the size of the wire, not the overcurrent protection. So if we don't have fuses or breakers, and you're on a service or secondary conductors off of a transformer, pretty much go to 250.66. Now, what it says here is 2-aught or 3-aught is going to be number 4 copper. Now, before that, what it says, and I got to find it here. I believe it's right here. It's going to be an A. Methods for grounding and bonding conductor connections to electrodes. So they talk about in here, they talk about pipes, they talk about rods, and they talk about plates. And that's in its own category of those 3. I'm still kind of trying to find it. I'm just going off memory right now. Let me see here. Structural. Please be here. Yeah, so pretty much those 3 are in the same category, right? Okay. Then it talks about cold water bonding in a different category. Then it talks about concrete encased electrodes in a different category yet. Somebody was confusing pipes being the cold water ground. I've never seen it personally, but what they're talking about is a pipe just like a ground rod would be, where you're driving the pipe into the earth. And that's where you want to maintain your spacing at 6 foot. If you're doing a supplement, number 6 maximum. So he looked in the code book and said, no, it says here, look a little closer. It says here, pipe 6, number 6. And when I first saw that, I was like, oh, well, it appears, I guess you're right. I'm going to look into this and get back to you. Well, I had time to look into it. And what it says here, rod, pipe, or plate electrode. So supplemental electrode required. A single rod, pipe, or plate electrode shall be supplemented by an additional electrode as specified. It shall be permitted to be bonded to one of the following. Now, what it says here is the bonding jumper, if I could find it here. Supplemental electrode bonding connection size. So right off the bat, it's saying supplement. So cold water being your main source, supplement would be something that supplements that. So we're already reading under supplemental, but we'll give them the benefit of the doubt. We'll keep on reading. It says here, where the supplemental electrode is a rod, pipe, or plate electrode, rod, pipe, or plate, there's 3 in one category. The portion of the bonding jumper that is the sole connection to the supplemental grounding electrode shall not be required to be larger than number 6. If we go over here to metal underground water pipe, which is in a separate connection point here, that's where it talks about it being number 4, as does the concrete encased electrode being number 4. So we've addressed that too.
Yeah, but I think the poor gentleman was confused because he didn't know the difference between a rod and a pipe.
I mean, maybe he's commented on quite a few videos before. So
well, you and I had discussed it, and the way he was saying it, I at one point in the conversation, I was just like, "This is pretty easy. Rods are solid, pipes are hollow."
Right. Right. And the other thing, man, the cold water ground doesn't necessarily have to be full of water. The whole point of the cold water is that it's not going to be on the hot water side, right? So it's going to be in the earth. It's going to be continuous because there's not going to be any shutoffs before because it's the cold water. And the requirements for the cold water installation is as follows. One page forward. One page back. Hang on. I got terrible glare in here. Must not be.
I'll see what I can do, you boy.
Metal underground water pipe. So the metal underground water pipe in direct contact with the earth for 10 feet or more, including any metal well cased and bonded to the pipe, and electrically continuous or made electrically continuous by bonding around insulating joints or insulating pipe to the points of connection of the grounding electrode conductor and bonding conductor is installed. So what it says here is pretty much if made continuous is what it's talking about, would be if this was a shut off here, if this was the water coming in and we had a valve or a shut off here, you would just take a clamp here and jumper that shut off. I can actually draw that on the whiteboard here for Paul W.
Is Paul here?
If made continuous. And then it says here, there should be something in here that talks about within 5 feet. And I would like to find it for you guys. But the whole point of the 5 feet is to increase the chances of it not having a shut off before. Because when somebody works on something, a shut off fails. Pipe typically doesn't. So you're going to be replacing a shut off every, let's just say 20 years, right? What are you looking at?
I'm reading the comments and laughing.
Yeah. I ground everything on my cold water PEX system. It's awesome. Yeah.
Oh, he added an addendum to
that. Your boy Ram wants you to.
I already answered him.
Oh, nice.
Joshua said, I even put a PVC nylon bonding bushing on my PEX line. So you can legit use water pipe for more than TV cable ground. Yes, and you should. Because the whole point in bonding your metal, the whole essence of bonding, the very beginning of it, it says here. No bead up. That's all you can use it for.
I'm looking at the electrical systems that are grounded shall be connected to the earth in a manner that will limit the voltage imposed by lightning line surges or unintentional contact with higher voltage lines that will stabilize the voltage to earth during normal operation. Okay, so that's your electrical systems. That's why they want them attached to the earth. So that's why we go to the earth. Now let's look at why we bond to anything metal. So, and I can't explain the whole earth thing. There's a scientific explanation for that. All I know is that it's kind of like a swimming pool. You want the same equal potential. So if you are able to get energized, you want that neutral and your earth to be relevant to the electrical system in your area, would be a good explanation for that. And just like I said, lightning is going to take the current back to, I guess, the source. So that's as far as I go with why ground rods are required. I don't fully believe in ground rods because they already require two. Holding up one finger. They already require two as a supplement because I already know that they're crap. So like, this one's already no good. We're going to require two because I already know they're not a great ground. Cold water is absolutely required. So we're going to hit cold water. If you have PEX, then you hit your UFER, which is a concrete encased electrode, which is essentially just a giant freaking ground rod over a wider surface area, which the porous concrete is in contact with the earth. That's why when I did that last short, we had them, they actually had the concrete encased electrode above plastic. And the pump truck was there. I don't know if you can hear it in the short. Pump truck is literally there. It's pouring concrete. And I said, dude, you got to get all this plastic out of here. And he said, man, it's just me here. I said, well, drill a hole through this bulkhead. Send me out 20 more feet. Tie it all together. And we'll catch it on the next one. Don't put plastic underneath the next concrete pour in the grade beam because that's where his UFER is going to be. And he already had the stub up. So we got a means to get out. I just got to see it on the next inspection. Difference of potential equals shocks the hell out of you. Yeah. Insulated gloves and go ahead.
So I just want to make sure that I understand this correctly. You had a professional.
This was a general contractor. The professional wasn't on site. The professionals are never on site, by the way. No one ever shows up for their own inspections. You can forget about that. That's ship sail.
Who was installing a swimming pool?
Not this job. Are you asking?
They were getting a deck poured for a swimming pool, and it never occurred to the electrician who was on site at some point that interrupting the pathway to the ground with plastic and insulator that prevents electricity from passing through it because it doesn't conduct, which would then in turn energize everything in its path. It never occurred to them.
So just so we're clear, that was the bonding for a whole apartment complex, not a swimming pool. But it was the ground for the whole apartment complex, and not a swimming pool, but
so much better.
That's probably true. Yeah, the concrete guys typically install that stuff, and then I'm just left trying to help them get past, pretty much. I would like to find the.
Look, not to knock electricians or any professional really, although most of them, not most of them, but a good share of them need to be knocked off their high horse a little bit. But the fact of the matter is that it's not nearly as difficult to figure out as they make it sound. The reason you want 16s on your studs is for drywall. It's for the electric. It's so that they know exactly where your studs are going to be. It's so that you can half them and get your next sheet up. Not hard. When it comes to electricity, again, don't want it to come back to you, through you, or into metal, because then you become the ground. Again, not hard to figure this stuff out. The fact that they've been doing this and getting paid for it and they don't know what they're doing, that says a lot.
Yeah. One wants me to use simpler words. I'm going to try. All right. So concrete encased electrode, okay? Concrete encased electrode would be a conductor, a wire, that is encased in concrete. Now, the reason why we encase it in concrete is because the concrete is porous. The water can get through it. It can make contact back to earth, okay? So I'm going to read this here. It says, it shall consist of at least 20 feet of either one or two. So we got 20 feet. It can either be one or more bars of zinc, galvanized, or other electrically conductive coated steel reinforcing bars, not less than half-inch in diameter. So it's going to be at least a number 5 rebar. Number 4, sorry, number 4. Number 5 would be 5/8, right?
I don't know.
Half-inch, whatever.
Just like your mom, bigger was better.
20-foot length, or if multiple pieces are connected together by the use of steel tie wires, exothermic welding, which would be CAD welding, which pretty much uses fire and powdered iron and all that stuff to melt. You can create 20 feet. So you can tie wire 100 pieces of rebar together that are at least half an inch in diameter to make 20 feet if you have to, legally, which is what we did there. Now, or a bare copper conductor not smaller than number 4. Now, sometimes, and you'll see a short on this, I'll roll up and they will have a number 4 in the slab. It's 20 foot long, and I'll see where they didn't even clamp it. You don't have to clamp it because they had at least 20 feet encased, right? If they have 5 feet of number 4 and it's not clamped, that's not going to work because the clamp, you have a listed clamp that's going to electrically be continuous, just like I said, listed clamps, exothermic, all that stuff. So that's what you call an extension of the concrete encased electrode. So extensions have to be to code to be qualified for a qualified extension, obviously. It says here, metallic components shall be encased by at least 2 inches of concrete. That way you get full encasement so nothing corrodes, just like we were talking about the galvanized rigid conduit corroding in the earth. Same thing here. Your rebar will not corrode if it's within 2 inches, encased in 2 inches of concrete. And shall be located horizontally within the portion of concrete foundation or footing. Notice it doesn't say flat work, it says foundation or footing. So foundation, by definition, is intended to carry weight. It also says or footing, which is intended to carry load.
Compression, yeah.
Yeah. So flat work is out. If you're trying to put it in the middle of a driveway, can't do it. That is in direct contact with the earth or within vertical foundations of structural components or members that are in direct contact with the earth. If multiple concrete encased electrodes are present at a building, it's permissible to bond only to one grounding electrode system. So that's why if you hit your UFER, you don't have to hit all the ground rods, all the cold water, all that stuff. That's why whenever I go to these brand new houses and they got that UFER, we're good to go.
Hey, you have a comment that you need to address there.
Yeah, I do. Let me see here. 4 is half. Yes. Thank you.
Above that.
Above that. Oh, what's up, Preston? It says here, you failed me for not derating. Don't say this. You failed me for not derating too many current conductors in a 40-inch pipe. Another master I talked said I should be able to do 10 feet because of exception 310.14.2. Let's look at that. And I will publicly apologize if I need to. 310 dot what? 14?
310.14.2.
310.14.2. 310.14.2. 310.14. There's 15.
Preston, don't worry. It's his first day learning how to read.
15. What the heck is 14? Conductors in parallel. 14.2.
310.14.
I don't know if he's jacking with me.
No, you know what? I'll bring it up for you. You're having all kinds of.
Bring it up because 310. I see 310.10.2. Are you talking about parallel?
Ampacities for conductors related to 0 volts.
To 10 feet because of exception 310. I know 310.15 too. Is there a typo?
Conductors for general wiring. Oh, I know what to ask. Never mind. Oh, see, I'm part of the new generation, the smarter generation. Pro V.
310.14 too. No, this is the 2023 book. We're not even in the 2023 code. I don't even have a 2023. We're not even calling 2023. We only just barely started the freaking 2020 beginning of this year.
Well, so correction factors in situations where the ambient temperature is above 30 degrees Celsius, 86 degrees Fahrenheit, or below 0 degrees Celsius, 32 degrees Fahrenheit, correction factors need to be applied to adjust the ampacity rating of conductors. These correction factors help account for the impact of temperature on the conductor's performance and ensure their safe operation. I don't know why that would create an exception. You live in
if it's 30 degrees C, you might be able to do a calculation that would say you can put more together, but without having the code in front of me. Yeah, the high ampacity is applied to portions of a circuit. Is that only in the 2023? Because we're not even in the 2023, so I can't.
Hold on, I'm going to send it to you in the private chat so that you have it in front of you, and then you can talk about it like not a moron.
Because he used a Makita. What's up, Kenzie?
There, check out the private there, and it's too long to post in the regular chat, guys. So I apologize to you for that.
I can actually copy paste it and bring it up on this something else.
There you go. This is what I am here for. I will find the information because I know how Google works.
310 of the National Electrical Code, which deals with conductors for general wiring purposes. Let's explore the details. Focuses on the sizing of conductors for certain applications, particularly those related to ambient temperatures and conductor ampacity. Here's the general information outline. AC
2,000 volts. Preston, we need to find out our UND to Makita user. Ken C wants to know. He threw down the gauntlet at you. We want to know if you're Makita Milwaukee guy.
Just tell me the scenario. What'd you put in the pipe?
Willie. There you go. Preston's right. No matter what he says from now on, he said M18.
Oh, there you go. Just tell me what you put in the pipe.
Willie. Oh. I learned everything I need to know from Google.
M18 all day. I learned everything I need to know from the machine. Yeah. Oops. Pulling up my book now. Okay. What you sent me in the chat didn't come all the way through because it cut out.
Shoot. Hold on.
It said they A.
Oh no, that's correct. Yeah. Don't even need school anymore. Google it. That's how I learned about all my testing tools with a couple of guys. I went to YouTube Tech. What's up, Richard? Glad you made it.
YouTube Tech.
I think I pinched a nerve in my neck. That's why I'm dizzy.
Uh-oh.
310.14 in 2020.
Okay, crap. I was afraid you were going to say that, dude. I specifically grabbed my 17. because my 20 has too many last names on it. It's at work. Okay, let me look it up. 310.14.
2020 code.
310.14.
No conductor shall be used in such a manner that its operating temperature exceeds the designated for the type of insulated conductor involved. Got it. Hold on, I'm running it. I got you. I'm gonna send it to you again, because that's the kind of guy I am.
Oh yeah, that's very nice.
Boom. Control C.
Portions of
And
circuit height and C shall be
I'm a private chatter for money. There you go. Just send it to you. Boom, boom. Too bad I can't copy the table and send it to you, though.
The total portion of the circuit with lower ampacity does not exceed the lesser. How recent was this?
I mean, he's still pretty bitter about it.
Yeah, I can see that. You should have reached out to me, man. We could have talked about the code.
310.15 now. Hold on.
I feel like I missed out. How long ago was that? Because if your building was permitted, like, 2 years ago or something, you only just got the plans a year ago. A year ago would probably be a 2017 code. If you got my phone number, I think you do. Tell me the permit number. I can look it up for you. We only just started looking in the code.
If you just look in the private chat, you're gonna find that some homeboy then hooking you up with all the answers right there.
Yeah. So, in 2020 AC,
failed him a year ago. He owes you lunch.
That says medium voltage. Hang on, we need less than 2020.
Preston, he owes you lunch, dude. All for him taking you out, whining and dining you. He did the last part first. Now he owes you the first. Whining and dining.
No, this is medium voltage. Hang on.
You can get this number for only $15.99.
It was on a rooftop.
Preston, if you promise to yell at him, I'll give you his phone number now.
310.15B1. B1.
You switch from 1 2-inch to 2 1 1/4.
So let me go to let me go back to the comments. What did he have in there? You switched from 1 2-inch to 2 1/4. What was in the 2-inch?
About 2 inches of space.
Probably had quite a few wires in there. Is this at a house?
I mean, I'm not really following the bunch of circuits.
I think I know where this was. I think it was at a house. Bunch of circuits, yeah. So the ambient temperature, if it was outside, your ambient temperature wouldn't be 30 degrees C. Right, based on 30 degrees C, 86 degrees. Because it's 116 degrees yesterday, the heat index.
Ohika.
Right, didn't it say if they don't go above 30 degrees C? Wasn't that the requirement?
If you check the private chat, I actually sent you all
ambient temperature correction factors based on 30 degrees C.
Yeah. Well, it was 30
degrees rays and cables exposed to sunlight on rooftop is now section 300.10b2, and the title was shortened to Rooftop. Table 300.b2a, ambient temperature correction factors based on 30 degrees C, 86 degrees Fahrenheit is now table In 2020, the relation to the medium voltage conductor requirements from Articles 310 is in 311, creating a domino effect resulting in renumbering the tables and code sections. If it's based on, isn't that what he typed, or did he just tell the code? He said the code.
He said the code. I didn't see the rest. I didn't see the explanation. It's fresh on his mind. So
yeah, plenty of room. Just basically, if it's 30 degrees C, 30 degrees C, it gets 105 out here, so that wouldn't apply. If you're in a freezer, or if you're in a building that wouldn't see more than 90 degrees or whatever.
Well, congratulations, Panther.
What's up, Panther? Figured out to become a member of Soul Chanel, I would make my own user error and become a member here too. Hey, man, I appreciate that. Thank you, sir.
Notice he didn't say becoming a member on my channel was an error. I'm just gonna throw that out there.
All right,
he might now, but he didn't before.
So let's look at that. Let's do this. Right? We got the dreaded paint. Okay.
I see a whiteboard and I want to paint it black.
Let's go to paint here. And let me drag that over here.
Take it easy, Ryan.
How come you can't see me move that? Oh, because I'm showing the screen, not the... oh, okay. Well, I may as well do it here then. All right, so now that I know we can see this, if we have... Didn't work. If we have... And we're permitted to use the 90 degree C column.
What's up, Mark?
Calculations. If we go to... I move my codes around so much, man. It's 310 dot.
I keep experiencing error to become a member.
Yeah.
Well, you should do it anyway.
90 degrees C. So let's say that we had number 12s, which we're allowed to use for 30 amps. Okay. If we go to this chart here, it says number of conductors. So 4 to 6 is 80%. 7 to 9 is 70. 10 to 20 is 50%. So if we've got 10 conductors, and being current carrying would be the neutral and the hot, the neutral carries the full load imbalance. So neutral conductor that carries only the unbalanced current from other conductors of the same circuit shall not be required. But that's going to be the unbalance from the other conductors of the same circuit. So that would be like a 3-wire where you've got 3 hots and 1 neutral, multi-wire branch circuit. So in a 3-wire circuit consisting of 2 phase conductors and the neutral conductor of 4-wire 3-phase wide connected system, a common conductor carries approximately the same current as the 2 line to neutral loads carries. So when you're dealing with a 120 volt circuit,
$5 sounds fresh.
The neutral will shock you just as bad as the hot if you get in between it. You got the same amount of amperage. You put a multimeter on the black wire or the white wire, they're both carrying the same amount of current. So in this case, your Romex would be hot and neutral will carry the same amount of current. So therefore, you have 2 current carrying conductors in your Romex. So 5 circuits is 10 conductors, which brings you to 50%. So by de facto, if you've got more than 10 current carrying conductors in that raceway, which it sounds like you've had every one of them in a 2-inch, you're already at 50%, which puts you half of 30 amps. And we're being conservative there because we started with 30 degrees based on the 90 degree C chart, which we're supposed to be using the 75 degree based on terminations, but we're permitted to go up to the 90 degree C. So we already started at 30 instead of 25. So half of 30 is 15. So you can only put those 20 amp breakers. They're only good for 15 amps. So you can't put wire that's rated at 15 amps on a 20 amp breaker. That's where that comes from. the exception you sent me looks like it's 30 degree ambient temperature. So I'm not sure, but if we did 30 amps at
Call it the G code. Well, if it's anything like the G spot, no one will find it.
30 amps with 10 CC and carrying conductors.
Joshua, you let me know how that works out for you.
80%.
Throwing a Diet Pepsi in Kansas is hitting on Preston.
Number 12.
Or right? Ken. He's hitting on Ken.
So 3 amps would be number 10. With 10 current carrying equals 50%.
Jamie, just because you have a G spot doesn't mean you know how to find it.
20 amps. No, sorry. Number 10. Number 10. So which would equal 20?
Can't see. That's the point right there.
And then that would be 15. Stupid. Again.
Preston.
Result.
Preston, in the one that you just cited, you are right. You need to run another one.
So, yeah, I think I do remember that house, unfortunately. I disagree, but my name's not on the permit. I got you. He claimed that 10% exception applied. Wouldn't it apply with, what's up?
Read 2 up above that.
In Dallas, we ran 2 inches longer than 2 feet with 4 240-volt inverters each. I told the other master we needed to add another pipe because of too many current carrying. He claimed the 10-foot exception applied. I disagree, but my name's not on the permit. Oh, yeah, I got you. So let's see here.
You were right, Preston.
4 240-volt. So did they have neutrals though? Because 4 240s would be less than 10, and that's typically number 10 wire. So how big was the wire? What was the size of the breaker? And 240 is not going to have a neutral, so that would be 2 hots per circuit times 4. That's 8 hots. So you'd be less than 50% automatically. So you'd be at 70%. 70% would get you, even if you were number 12, which I don't think you would be. You'd probably be number 10. You should be number 10. That would get you 25 amps. 70% of 25 should be 16.5 or something like that, right? So you go to the next standard size on 240.6. If you're less than 800 amps, you're permissible to go to the next standard size. And since you fell on an in-between size, in between 15 and 20, you're on the 16 of that. You can go up to the next standard size, which should be 20. But if you're at number 10, then you're good all day because that's 40 amps, 90 degrees C. Even if you had 10 current carrying conductors, you would still be at 20 amps flat.
Number 6 THHN with neutral.
Oh, number 6 with neutral. Okay, so number 6 is good for 75. And then we had with neutral, so but that's going to carry the imbalance because that's just powering the inverter, right? You would know this because you're solar. Yeah. So the neutral is not actually carrying half of the load. Nope. So actually, in this case, based on those exceptions that we read, the neutral that carries only the unbalanced current from other conductors of the same circuit shall not be required to be counted when applying provisions for 310.15b3a, which is the table we're using. Uh-huh. But if we wanted to entertain and say the neutral is required, because I want to do the calculation now because I'm a nerd, that would be 4, and then 4 again, that'd be 12. So
just so you guys know,
50%
he touches himself looking at panel boxes.
So 50. Well, why do you think I got all this footage when I'm in the field? So 50% of 75 would be 35. No, wouldn't it be 37.5 or something? So 40 amp breaker. Is that what he said?
60.
He put on a 60 amp breaker.
Yeah. Multiple inverters. Yeah. No, not on solar.
Just 20 amps, right?
Yeah.
For a string.
Yeah.
Typically, number 10 is good to go all day. You're looking at a plan review and you see number 10 go into a string, DC or AC.
Yeah.
Typically speaking, you can't exceed 10 amps. It's almost impossible to.
Got 8 total inverters going through it. With this being solar, yeah, you're good with what they did. You don't have any issue with it because it's solar. If it was like not solar though.
So 8 total. What was the breakers though? Because if they're 20 amps, number 6 is going to be good to go all day.
60 amp breakers, sir.
60 amp breakers.
He's still good because you can go up to an 80 amp on it. So you're doing a 60, he's good.
No, because he has 8 total inverters, so he's got, what does he have? He's got 60 amp breakers. Okay.
That's a nice commercial job though.
4 240 volt inverters. But then he said he had 8 of them, right? He changed it. Okay. So 8 total. So that means he had 16 current carrying conductors. Yeah, 60s probably wouldn't fly. Or that wire probably wouldn't fly. You're right, because you start with 75 degrees and then you got to derate based on if he's got 8 inverters and they're all in the same raceway. You get them in the same raceway, right?
Mm-hmm.
Yep. In the same raceway. That's going to get you 10 to 20, which is 50%. So maybe 40 amp breakers, but that wouldn't supply your load. So you would have to go up to, if you want to put them all in the same raceway, you would have needed to go to maybe a number 4 might have gotten it at 95 amps. Half of 95 is...
Take it easy, Kansas.
47, so 50. Nope, can't go to 95 either. You have to go to number 3 to put them all in that. All right, Kansas, appreciate it. We'll see you on the next one.
He said he used 2 2s.
2 2s. Oh. What?
He's good.
2 2s.
Yeah, he's good on this.
Yeah, 100. This is one building, 2 number 2s per.
Yeah,
inverter.
He's good all day.
Per inverter. Yeah. Oh, this is a different scenario.
Yes.
Oh, okay, cool. Yeah, 2 2s is good all day. That's 130. So half of that would be, even if you counted the neutrals as current carrying, which I don't see you would, because your inverters are supplying 240. Your neutrals are only going to supply your rapid shutdown and your communications, correct? And a path back to the source to trip the breaker on a ground fault, of course.
Mm-hmm. Yeah.
So, but as far as current carrying, no, that would not be considered current carrying. Under my goodness, going blank on that.
Well, the rules for solar
under an objectable current path where you don't intend to have current all the time.
Yeah, the rules for solar are completely different than.
Yeah, and then you got a whole different list of set of rules than that. So yeah, you're good to go on number 2 all day because that would most certainly get you.
Don't worry about it, Preston.
Yeah, no worries.
Until I found out it was solar, I was with you. Once I found out it was solar, I was like, oh hell no.
Okay, so back to the whole beginning of this code, and then we're going to wrap it up. We're going to get out of here. Somebody asked about
Are we just leaving the whiteboard up now just for fun?
No, we're not leaving it up for fun. Here we go. All right, so where are we? We're going to go to the beginning of this code book. Okay. Objectable current. So we talked about the current carrying and all that to the earth, right? But this is where you're talking about bonding all your steel to get your current back to the source. So it says the grounding of electrical systems, circuit conductors, surge arresters, surge protective devices, and conductive normally non-current carrying metal parts. So anything metal that's able to carry current shall be installed and arranged in a manner that will prevent objectable current. Now, it goes on to also tell you about anything likely to become energized. So the path for fault current, electrical equipment, wiring, and other electrically conductive material likely to become energized shall be installed in a manner that creates a low impedance circuit from any point of the wiring system to the electrical supply source to facilitate the operation of overcurrent devices. Should a ground fault from a different phase occur, the earth shall not be considered as an effective ground current path. You can't create enough current when you're going to the earth to trip a 20 amp breaker. Your whole grounding system is based on 25 ohms to ground. If you don't have that, you got to drive another ground rod. So to the own argument of these inspectors that say, oh, well, you've got to have a ground to trip this breaker, you have to have more ground rods. It's all BS. That's why I don't fully believe in ground rods, because they don't actually trip your breaker. They do like an equipotential bond plane like we talked about before. So what all that means is if there's anything metal that can become energized, it needs to be bonded back to the source. How do you bond it back to the source? Your equipment grounds go back to the neutral. That's where your main bonding jumper, your system bonding jumper, all this stuff comes into play. So you can get current on your neutral, go through the windings of the transformer, and trip that overcurrent device. That's what it says, facilitating the normal operations of overcurrent devices or fuses. So that's why we bond everything metal, and we try not to create parallel paths, because if you have a parallel path to ground, it acts as a neutral. So if we've got two neutrals landed from one sub panel to the main, you're going to create a parallel path where you're dividing your current in half. The same thing happens when you land a ground on your neutral bar when it's supposed to be isolated. It thinks it's a neutral because they don't know color, they don't know anything. They just see I'm landed in the same spot. So now we've divided our current in half, and we wind up with current on our ground wire. And that's what a parallel path essentially means. And it talks about parallel paths in here. I'm not going to bore you with all the details, but
bonding
pretty
with
much your effective ground fault current path, electrical equipment and wiring, other electrically conductive material likely to become energized shall be installed in a manner that creates low impedance circuit facilitating operation, blah, 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 blah. It's all the same thing down here. You just read through, and that's in the beginning of Article 250 under electrical system grounding. Tools with grounds, yeah. That's it, man. It's all based on your grounding. It's the base of everything. If you're not grounding and you don't have a way to get current back to the source, you cannot trip that breaker. It's impossible. You'll create a high impedance to where you're starting to arc, and that's when you have fires.
Yeah.
So if it's trying to get to ground and there's not a good source for it, it's going to try to find it. That's when you get a high impedance ground. High impedance being more resistance meaning a stove unit, stove resistor, whatever you want to call it, is essentially just a bunch of resistance. You got a hot on either side of that, and the current meets in the middle, and it's so much resistance that it doesn't trip the breaker. Pretty much it's almost like a short circuit, except that there's so much resistance that it can't short out. The same thing with your body. When you touch electricity, your foot's grounded, you touch the hot with your fingers, there's so much resistance in your body that you can't trip the breaker on a short circuit. Same thing. So you turn into a light bulb. You just start lighting up, and then your organs fry. All right. You guys have a good day. We'll see you guys in the next one.
And don't forget, all you Makita guys out there, love them like you know
Yeah.
them.
Tell that to every other civilian DFW that makes us want to disconnect for line side taps. Dude, I almost gave up on it. It's so upsetting. It's the path is so minimal, and it's not like it's from a sub panel to the source that even if it is a parallel path, I just gave up on it. Yeah, Jamie, true. Take it easy. We'll see you guys in the next one.
Hey, click off that comment. I want to show everybody something.
Yeah.
Click off that one.
I'm trying to. There we go. Not the coffee one?
Not the coffee ones. No coffee grounds.
Oh, Tools with Grounds. Oh, I didn't even know you changed your name, bro. I heard that in the comments. Hey, before we go, someone requested you show your 12 volt with the Gen 4. Did you do it?
Did you see me do it?
No, I didn't see you do it.
Then I guess I didn't do it.
Look
And they'll
forward to
just
it.
have to tune in for me to do it on my channel.
That's right. We'll see you guys in the next one. Thanks for watching. Thanks for dropping by, Preston. And everyone take it easy. See you later. Bond your finger with that subscribe button. That's right. Later.